Hello everyone. Now let's try to solve this particular question. A queue is implemented using an array of size 5, that is basically circular queue here. Now we should know the concept of circular queue first. Okay. The following operations are performed. You can see enqueue and dequeue. I hope everyone is aware about what is enqueue and dequeue. Enqueue means what? Simply you can say that we are going to add the element inside the queue. Dequeue means what? We are going to remove the element. And how we add and how we remove the element in the queue based on the first in first out principle. This is what we have discussed, right? But what about circular queue here? Let's try to understand that first. So we know about the normal queue, right? Inside the queue, what we do? If we have this particular array like this, right? So 0, 1, 2, 3, let's say for example 4, right? So we say NQ operation, NQ 10. So we are going to add the element 10 at index position 0 here. Now when I say NQ 15, we have to add the element at the next position, that is basically a 15 here. Then if I say DQ here, so what does this mean DQ? DQ means we have to remove the element, but which element? Based on the first in first out principle here, that is basically whichever the element enter the queue first, that we have to take out. So we have seen that 10 has entered the first, so 10 will be taken out here like that. And if the next element is basically NQ 20 here, in that case this 20 will be added at index position 2, even though the index position 0 is empty here like that. Okay, so this is about the queue in general. Now what about the circular queue here? What about circular queue? It also works on the first in first out principle, but the only difference is that the array is basically circular here. It means what? The last position is connected back to a first position here like that. So if I draw a diagram of circular queue, so let's say for example like this, and let's assume that this is basically a circle. So here 1, 2, 3, 4, 5. So index position 0, this is 1, this is 2, this is 3, this is 4. This is basically circular queue we can say, right? Now you can see the last position is connected to a first position here. Now see what happens here. Now initially here we have two things, rear and front end here. Okay. So rear and front both are basically -1 we can say. So let's assume rear is basically equals to -1 and front is also equals to -1. The moment we perform the NQ10 here, we have to add 10 element at index position 0. So we have added that. Now at this particular point, when we add the first element, the rear becomes 0 because at 0 position we have a rear element, and front is also becomes 0 here. You can see 0, 0, right? Now if we add the next element, that is basically NQ15, now 15 will be like this here. It means what? The front will be what? 0 only, and now the rear will be what? 1 here, right? And now if I DQ the operation here, let's say for example, let's say we will add one more NQ operation here, NQ17, okay? So NQ17 will be what? At index position 2 here, that is 17 here. In that case, rear will be what? 2, right? Sorry. In that case, front will be a 0 only, but rear will be a 2 because here we have 17 included. So this is basically my front as of now. This is basically a rear as of now. So what you observe here, right? When we enqueue here, what happens? Rear is basically what? What's the position of rear? Rear is basically rear plus 1, and it is equals to what? So basically rear plus 1 mod of n, and is basically what size of this particular queue. Let's say for example 5 here. So whenever we are performing the NQ operation, what happens? Rear position get changed to rear plus 1 mod of n here like that. Let's say for example, now we perform DQ operation. DQ means what? Whichever the element enter first inside the queue, that will be taken out here. So this will be a DQ here. Right now, this is removed. So if this is removed, this is basically empty here. If the position 0 is empty, in that case, front will move to this particular position, that is basically 1. Right? So in the case of DQ operation, what happens? In the case of DQ operation, what happens? Front is basically a what? Front plus 1. Front plus 1 mod of n. And in the case of NQ operation, what happens? rear equals to rear plus 1 mod of n like that. Okay. I hope you understand the NQ and DQ operation now, right? Now what happens, let's say for example, we'll keep adding the elements here. Let's say after dequeuing, we are adding 20. So we are not going to add 20 at the empty space. We have to add 20 at the next element here, that is basically next position, that is 20 here. Now what happens? Rear position will be changed here. Now this will become my rear. Okay, this is rear now, and front will be position 1 only. So rear is 3 and front is 1. Again, we are going to perform the NQ. Let's say, for example, 30 here. Again, NQ means what? We have to add the element that is basically here, 20. So rear becomes now this one at index position 4 here. That is basically my rear, because you can say rear is what? 3 plus 1, that is 4 mod, and that is basically 4 only. But now what's happened? Now what happened? Let's see. If I again perform NQ operation, that is basically let's say 50 here. Now we know that this is basically empty. If this is empty, now let's see what's happened here. NQ 50 means what? What will be the rear? Rear plus 1. So 4 plus 1 is basically 5. 5 mod 5 is basically a 0. Now this will be at position 0 here. That is basically 50 will be stored here. If the space is empty, then we can add the element 50 here. If the space is not empty, then we can say the queue is overflow. Okay. I hope you understand the concept of circular queue here. Simple concept here. Okay. So just remember this thing. You can expect simple 1 mark question on this. In the case of NQ operation, we say rear equals to rear plus 1 mod of n. In the case of DQ operation, we say front equals to front plus 1 mod of n like that. Okay. Now, if you understand this thing, let's try to solve the question now. Now, let's come back to this particular question. Here we have a circular queue. So, you can also create a normal queue like that, but it works in a circular manner. Remember this. So, here we have 5 sides here. So, 0, 1, 2, 3, 4. So, 0, 1, 2, 3, 4 here, right? Now, let's see the following operations are performed. First is NQ1. So, we are going to add 1 here. So, here my rear is basically initially -1, front is also -1. The moment I add the element here, now here this is basically front also 0, rear also 0, this is 0 and is also 0 here. Now NQ2 is basically we have to add here, right? That's it. NQ3, next element at index position 3 here. Next element, that is basically 3 at index position 2, that is 3 here. Now what happens here? DQ. DQ means what? Based on the first in first out principle. So we have to remove this one, that is 1 from the array. So we have removed this one. We have removed this one, right? Now you can see this becomes my front and this becomes my rear now, right? So front is basically a position 1 and the rear is basically a 2 here, right? Now next operation is basically NQ4. So we have to add the element 4 at index position 3 here like that. Now here rear is basically a 4, right? Next is basically NQ5. So we have to add the 5 at index position 4 here. Now the rear becomes 5 here like that. Okay, so rear is basically index position 4 and the front is basically 1 here. Now let's see what happens. We have NQ6. Now where the 6 will get added here? If you observe in the case of NQ operation, what I said, rear equals to rear plus 1 mod of n here. So rear is basically 4, 4 plus 1, 5, 5 mod of 5 is basically 0. So we have to add the element 6 here because it is already empty, because we have removed this. If the element is present, in that case we can say it's an overflow condition. But here we have the empty space. So we are going to add this element 6 at this particular position 0. So we are going to add 6 here like that. Next we have a DQ here. DQ means what? Now which element is going to DQ here? So as of now, this is basically my, which one is rear end? So this is basically a what? Now this is basically a rear and this is basically a front, right? So whichever the element enter the queue first, that is going to take it out. So front is basically 2. So we have to remove this from the queue here. So we have removed this from the queue, right? Now my front will be here. So this will be my front. Now what happens in the case of again DQ operation? Again we have to remove the element. So again we have removed this one. Now this front become this one like that. Okay. Now that's it. We have performed all the operations here, right? So if you observe what will be the array now here. So this is basically 0, 1, 2, 3, and 4. So 6, this empty, empty, 4 and 5 here. Now this is basically my front and this is basically my rear end now, right? Now what we want, what will be the content of the queue after these operations have been performed, and you can see front to rear. So you can see in the option that will be what, 4, 5, 6, that is front to rear here. So this is the correct option here. Okay. So this question is part of my test series. You can check out my GATE DA course as well as a test series here. Okay. But I hope you understand what we have discussed in this particular video and the concept of circular queue. Now, there are a few important points that need to be remembered in the case of a circular queue. So, if you observe, when we can say the queue is basically full. So, let me write down two important points here. Okay. So, whenever the value of front is equals to -1 or rear is equals to -1, it means what? The queue is basically empty. Queue is empty, we can say. Queue is empty, we can say, right? Now, when the value of front is become equals to what? Rear plus 1 mod of n. In that case, what we can say? In that case, we can say Q is basically a full. It means what? It's overflow condition here. Can we say like that? Yes. So for overflow condition, the front equals to rear plus 1 mod of n here. Right, so if you observe here, if I didn't perform any DQ operation in between, let's say for example, we have not performed this one, so in that case, 1 will be there. If I did perform this one, in that case, a 2 will also be there, right? So this will be an overflow condition here in that particular case, and you can observe rear is basically equals to what? Sorry, front is basically equals to what? Rear plus 1 mod of n here. Remember this condition here, right? So whenever the queue becomes full or overflow, this is the condition that will get satisfied here. So remember this condition, you can expect a simple 1 mark question here. And this also, what happens in the case of NQ? Rear will be what? Rear plus 1 mod of n. In the case of DQ operation, front will be what? Front plus 1 mod of n here. So this point, and this important point you have to remember in the case of circular queue here. So if you want to visualize this particular concept, let's try to do that. So we'll consider this particular queue only 1, 2, 3, then DQ 4, 5, 6, then DQ, DQ. Okay. Let's try to visualize this particular case now. Okay. So here you can see circular queue visualizer. It's on my website only. You can just refer to that here, right? So what we have done, let me clear the queue first here. Yes, so you can see here we have a size 5, so you can select the size of the particular queue here. Now we have first added 1 here, so 1 is NQ, so you can see front and rear both now at the same index position. Now it is 2, so we have to add 2 here. Now front becomes 1, 2 becomes rear, then we have 3, we have NQ operation here. Now you can see rear got shifted to 3 and index position 2 you can see. Then we have a DQ operation here, right? If you observe, we have DQ operation. Yeah, we have DQ to 1, you can see. Now what happens here? Front is basically at index position 1, rear is basically at index position 2. Same thing what we observe. Now we have 4 is NQ, then we have 5 as NQ, then we have 6 as NQ, right? This is what we got here, right? Now if I DQ, DQ, so this and this will get removed. So we are going to get the resultant 1 here. But now if you observe here, the queue is basically a full. So if I try to insert one more element here, let's say for example 7, let's see what happens, because we don't have any empty slot here, right? You can see overflow condition. It means what? Here rear will be what? Rear plus 1 mod of n. So rear is basically 0. Front is basically 1. So rear plus 1. So 0 plus 1 mod of n is basically what? 1 here. So you can see front is basically equals to also 1. So in that case, it will lead to overflow condition. So when we are trying to enter the queue, what happens here? Why throw an overflow message? Because it calculates rear equals to rear plus 1 mod of 5 here, that is basically equals to 1, which matches the value front 1 here. In that case, is throw an error, that is basically overflow condition here. Okay, I hope you understand this particular keys now. And if I simply dequeue this one, so we have removed 2, then we have removed 2. So you can see the front becomes 4 and the rear becomes 6. So 4, 5, 6 will be the answer here. Okay, so if you want to visualize, if you want to practice more uh, operations here, you can just refer to my website. This particular link I will share in the description. You can just go through that. Okay, you can see circular queue visualizer here. But I hope you understand what we have discussed in this particular video. We have covered the concept as well as we have solved one question. Okay, so that's it from my side. Thank you.